I'm going to erase that and clean it up too. Okay, remember when I was talking about the periodic table and I said this column all has one valence electron. This column all has two. This one has 3, 4 for this column, 5, 6, 7, and 8, right? So that stands for the valence electrons, VE. I know I'm not fancy, sorry. Okay, remember our atomic number equals our protons and our electrons, right? And then the mass the AMUs equals the neutrons plus the protons. So if we want to find out how many neutrons there are, we take the AMU, the atomic mass units, and subtract the protons. And this is also the atomic number, okay? It's just a hint. And that's how we can find out how many neutrons we have. Okay. I'm going to first start out with the Lewis dot structures because it's going to have to do with this 1, 2, 3, 4, 5, 6, 7, 8. If I were to take boron right here, how many valence electrons does boron have? I can't see my chat right at the second. Would someone open your mic and tell me how many boron valence electrons it has? It's in this third column. It has 3. It's in the third column, so it has 3. So we can draw, thank you. I got it from somebody here, let's see. It's okay, Manny. It's all right, Felix. Simple math. Okay, it has 3. It has 5 electrons total, but only 3 in the outer shell. Okay, so our Lewis dot structure looks like that. Our Lewis dot structure could also look like that. It doesn't matter. It doesn't really matter where you draw the dots. I've just been taught to do it this way. You start like a clock and you work your way around, but it's really not critical. I think the example on that page gave us something that had them side by side, and that's perfectly acceptable. Some teachers will have different ways. So now if I did chlorine right here in the middle, chlorine has a total of 17 electrons because that's what our atomic number is. But how many valence electrons does it have? Well, let's look at what column it's in. Dakota got it. It's got 7 valence electrons. So we would draw it 1, 2, 3, 4, 5, 6, 7. Okay. A valence shell can usually hold 8. So right here, there's one missing. Okay, that's all right. That's to clue you in on what's to come. That's how chlorine will bond. It's going to bond with something over here. You guys have probably heard of potassium chloride or sodium chloride. It's because sodium and chloride have bonded. So that's going to help you as we work on the future. Come on, give me a pen. As far as the Lewis dot structures are concerned, let me see if it's giving me a pen. It's not. There we go. Okay, so if I did aluminum, aluminum is right here. So how many electrons are in the outermost shell of aluminum? Well, I look up here at the top and there's a 3, and that's how many dots aluminum is going to have, because it stands for how many electrons are in the outermost shell. Yadira, go ahead.
For the annotating, when it has those questions, are we annotating to answer those questions? Or are we just annotating like what we think is important?
You're annotating the things that are important, what the main ideas are, and then anything that you might have question about, so that you can write a question about that. And then you'll answer the questions in the little text box part.
Okay, thank you.
You're welcome. So are you guys starting to see how this works? Remember the Bohr diagram, we're going to start with our nucleus. The first level will always hold 2. So if I were to draw oxygen, oxygen's atomic number is 8. So that tells me altogether it has 8 electrons. So I'm going to draw the first 2, 1, 2. Then I need some space for the other 6 to go. So I make a next ring out, and the other 6 are going to live on the second ring. So there's 4, 5, 6, 7, 8. And it still has 2 more spaces on that ring. If I were to make this fluorine, it has 9 altogether. So I would add 1 more. And that makes it fluorine. Then if I wanted neon, I'd add 1 more. Oops. Gotta get my pen back. It's not gonna let me. There we go. So neon is number 10. I've got 2 electrons, and then I've got 8. So that gives me 10 altogether. So then I come over here to sodium, and it's 11. Well, this ring already has 8, and it won't take any more electrons in that ring. So I need to make a new ring. And it's got 10 already here. So adding 1 more, now I represent sodium. Magnesium has 12, add 1 more, 12. So this ring can hold 2, this ring can hold 8, and then this ring can hold 8. And then we're going to stop. We're not going to go any farther than that. There are some other rules and stuff, but for what we need to know in this class, that's what you need to know. Okay? So the total can be 2, 8, and 8. I will write that. 2, 8, and 8. That 2 is terrible. Okay. So does anybody have questions about either the Bohr diagrams here or the Lewis dot structures up here? Very simple stuff. The Lewis dots, you just remember which column it's in. And the maximum dots it can have is 8 because we're only looking at that last circle. And if boron has 3 dots here, it's going to have 3 dots in the outermost circle on the Bohr diagram too. Okay. Since there's no questions, I'm going to try to stop sharing and I'm going to stop the recording.